Hi guys, Tony Josephs here guys. Welcome to my technology channel. Please subscribe guys, I need your support as usual. Anyway, how you guys doing? Hope your week's going good. Okay, today's topic of discussion is technology. Under the technology zone that I'm in, we're going to be discussing what is the RSA algorithm. What is the RSA algorithm? RSA stands for Rivas Shamir Adelman. These are the three researchers and mathematicians that came out of MIT back in 1977. They co-invented the RSA algorithm. The RSA algorithm is an encryption algorithm. It's an asymmetric encryption algorithm. Asymmetric means that it uses a public and a private key that is mathematically linked in key pairs to be able to encrypt your sensitive data and to decrypt your sensitive data. The public key is created and the private key is created, and they're both mathematically linked. The public key is sent to everyone, and the private key is kept secret. That's an important point. Now, the public and private key. The public key and the private key can be used to encrypt your data, but only the private key can be used to decrypt your data. I'll say that once again. The public and private key can be used to encrypt your data, your sensitive data, but only the private key can be used to decrypt your sensitive data. It's an important point right there. So like I mentioned, this RSA algorithm uses an asymmetric algorithm which uses two keys, a public and a private key, to encrypt your sensitive information. Only the private key can be used to decrypt your data, your sensitive data. All right, I just want to establish that fact. I know that this is not an easy topic to discuss, but let me move on down the road. So, the RSA cryptography uses both the public and the private key, which can encrypt and decrypt your message. So, one of the major attributes and one of the reasons why RSA has become the most popular used asymmetric algorithm is that it provides a method to assure the confidentiality, integrity, authenticity, and non-repudiation of electronic communications and data storage. Many protocols today uses the RSA algorithm. These protocols include Secure Shell, SSH, OpenPGP, SMIME, and SSL TLS. They all rely on RSA encryption and digital signature functions. It also uses software programs such as browser software such as Edge and Google. They also rely on RSA. If they use RSA, they can establish a secure connection over an insecure network like the internet. So we can use RSA to secure our connection over the internet. All right. RSA signature verification is one of the most commonly performed operations on network connected systems today. It's performed a lot, guys. So I'm not going to get into the inner workings of RSA. It will be too long of a discussion to mention that. I just wanted to mention that the National Institute of Science and Technology, NIST, recommends that a minimum key length of 2048 bits for RSA. So previously, RSA was using 1024 bits, and it could also use 2048 and 4096 bit. But 1024 bit has been under attack, and NIST recommends you using 2048, the minimum key length and bit size for RSA. Now you can double that to 4096 bit, but you'll have a performance trade-off if you do that. 4096 bit is allowed, but it won't be as fast. This is not a very fast algorithm anyway. But if you do need to double it, there'll be a performance trade-off if you use 4096 bit, which is totally allowable. So just want to mention just a quick word on what is the public key cryptography. It's the same thing that we've been discussing. What public key cryptography is, it's also known as asymmetric cryptography, where you use two keys that are both mathematically linked, one public and one private. The public key can be sent to everyone and shared by everyone, and the private key will be kept secret. Same thing, guys. Same thing, just different language. All right, so that's RSA in a nutshell, and I hope this was beneficial to you guys out there that seems to see it a lot but don't know what it is. A lot of your certificate management teams out there uses RSA for certificates and for code signing. You see this often. They use a public and private key to send information from one recipient to the next. And this information can be verified by sending that public key, and if you wanted to decrypt that information, you'd have to use your private key to decrypt that information. So that's the important side of all of this. Many certificate management teams use that today. For example, if they're using Venafi software, you'll be able to see RSA algorithms at work asymmetrically, using a public and a private key to encrypt sensitive information over the internet. Okay, guys, that's all I got on RSA. I just try to simplify it for you. There's a lot more mathematical, computational, factoring, priming involved with this, which I am not going to discuss. I just try to simplify things on what it is real briefly, and I hope that helps you guys. Thanks. We'll talk to you soon, guys. Have a good one. Please subscribe to my channel. Thanks. Bye.